Right class, now we are going to chapter 8, analysis of variance and chi-square test. Okay, first topic we're gonna learn about one-way analysis of variance, or we call it as ANOVA. Okay, so look at your notes. The F-test is used to compare the two variances, can also be used to compare three or more means. When the F-test is used to test the hypothesis concerning the means of three or more populations, the technique is called analysis of variance, or we call it as ANOVA. Although the t-test is commonly used to compare two means, it should not be used to compare three or more means. Okay. So, before this, we have done study about hypothesis test for 1 and 2 population. Okay, but now we're going to test for 3 or more populations. Okay, so we're going to use these techniques. We call as ANOVA. Okay, so the ANOVA can only show whether there is significant difference exists or not among the means, not different lies. Okay, look at the assumption of ANOVA. The following assumptions apply when using the F-test to compare three or more means. Okay. The population from which the samples were obtained are normally distributed. This is for number 1. Number 2, the sample must be independent of each other. And the last one, the variances of the population must be equal. Okay, for ANOVA, for chapter 8, we are still in reject or fail to reject H-note. Okay, concept dia. Okay. So we're gonna test, okay, whether there is significant difference exists or not among the means. So we're still gonna use the 5-step hypothesis testing. So the first step, we need to state the hypothesis and identify the claim. Okay. For H-note, okay, the notation for H-note is mean 1 equal mean 2 equal mean 3 equal until mean k. Okay, we're gonna test 3 or more populations. That is why we have 1, 2, 3 and k. K, what is k? The number of samples. If we have 4 population or 5 population, then you need to state M1, M2, M3, M4 until M5. Okay, if we have 5 population. If 6 population, then you have to state until 6 population. That means you have to state mu 6. Okay, so k is the number of samples. Okay, so this is the notation for H-note. For H1, at least one mean is different. Inside short form is different from the others. Okay, so H1, it is fixed. Awak kena ingat ini. Okay, dia tak ada, it does not have more than or less than. Okay, it is fixed. At least one mean is different from the others. Okay, so this is fixed. Okay, for H-note, refer the number of samples. If we have 3 or 4 samples, then you need to state lah until what the number of samples. Okay, so this is the notation for H-note and H1. This is first step. Okay, state the H-note and H1. Second step, you need to state the alpha. Okay, level of significance, alpha. Okay, and then critical value, F alpha. Okay, critical value, CV. F alpha, K minus 1 and minus K. Okay, alpha, it will be given in equation. Okay, K minus 1 we let as V1 and minus K we let as V2. What is V1? It is mean the degree of freedom. Okay, DF, that means degree of freedom for numerator. For V2, degree of freedom. Okay, DF ni degree of freedom for denominator. Okay, later I will explain from the example. Okay, and then so this is second steps. Okay, you need to state the alpha and the critical value. Okay, critical value f alpha k minus 1 and minus k. Okay, and then step 3. Step 3, you need to determine the rejection and non-rejection region. Okay, refer pada notes awak. Okay, so step 3, you need to draw the graph, and the graph always be the right side. The rejection region always be on the right side. Okay, so this is RR and RR. Okay, this is concept for ANOVA. Okay, remember always on the right side, the rejection region. Okay, so RR and RR. So this is step 3. Okay, and then step 4. Step 4, you need to use formula, the F-test formula. Okay, F-test formula. It is MSR divided by MSE. What is MSR? MSR, it is mean square residual. Okay, kalau tengok pada table tu, ANOVA table. Okay, MS adalah mean square for residual. Okay, it is population variance between the sample mean. Population variance, we need to find the population variance between the sample mean. MSE, mean square error. Mean square error. Okay, we need to find the population variance within the samples. Okay, so how to calculate the MSR and MSE? We need to use the ANOVA table. Okay, ANOVA table. Okay, look at your notes. Ada ANOVA table kat situ. Okay, so this is 1, 2, 3. Okay. So, kalau tengok pada source of variation tu, we have residuals. Okay, we have error and total. Okay, so the first table, okay, the first column is sum of square. Okay, ni saya short form kan as SS. Okay, short form SS. That means sum of square for residual. Okay, we need to calculate for sum of square for residual, and then we can get the SSR. Okay, and then we need to calculate the sum of square for error. We get SSE. We need to calculate the sum of square for total. We get SSC. Okay, macam mana nak calculate ni? Later I will explain from the example. Okay, based on example nanti. And then the second column is degree of freedom, DF. Short form as DF. Okay, for residual, K minus 1. For error, N minus K. And then for total, N minus 1. Okay, and then mean square. Okay, the third column, mean square. Okay, so we need to calculate the mean square for residual. We can get the MSR. Okay, and then mean square for error, we can get the MSE. And last one, you can calculate for F-test. Okay, this is the final step. Okay, the final step that you need to calculate. For F-test, it is equal MSR divide MSE. Okay, so nak calculate to use this formula F-test, MSR divide MSE, you need to use this ANOVA table. Okay, cara nak calculate tu, later I will explain based on example. So this is the terms. Okay, this is the terms that we gonna use to calculate for ANOVA table. Okay, ANOVA table ni. Okay, and then this is step 4. Last step, step 5, which is you need to state the conclusion. Okay, as usual, whether you have to reject or fail to reject the H note. Okay.